Hello everyone. So in this video, we will be discussing about the adapter pattern. This is the first structural design pattern that we will see. If you want to know what are structural design patterns, you can click on the link in description that provides the link to the video. Alright, so let's see what we are going to learn today. We are going to learn what is the adapter pattern and how to make its UML diagram and what does it convey, how to implement it using Typescript, and at last interview question. So let's move on to this first thing. What is adapter pattern? This pattern deals with interfacing two objects without changing their implementation path. You want to call new objects using an existing interface, but because they don't have something in common, you use a wrapper to connect them. Wrapper to connect them. This thing. So let me tell you what happens here. See, there will be two classes with two different interfaces and different functionalities. Okay. Now what happens is that you want to use both of their functionalities and you just want to call one interface, but you want to utilize the functionality of other interface as well. But since those two are incompatible, you cannot directly call them. I mean, it is not like you can do inheritance. Okay, if you do inheritance, then it will be a mess up of a code. So, in order to solve this problem, we use the adapter pattern, which creates the wrapper that will call the first interface and then it will be able to implement the functionality of the second interface as well. Here, the client will then be free to choose between the two functionalities with only one class. Okay, so let's see how is the UML diagram for it. If you look at this closely, there are two different interfaces which are incompatible, call API v1 and call API v2. So those two can be different APIs. There is implementation of this interface as well. Now, what you see is there is an adapter. This adapter has a service field called as API client v2 and it is having a method API v1. In this way, it does implement the functionality of these two interfaces inside of it. And then here in the client, you have a field API service v1. You can use the v1 services as well, and then you can use the v2 services through this adapter, not through this one, through this adapter. Okay, so the API client v2 adapter class solves this issue by aligning the interfaces so that client can use the method from API client v2 without changing its own interface reference. For example, the client would not need to add another service object with an API service v2 type. So yeah, it is true that we will not need to add another field in this service 2, which will be having a type API service v2, and then we will call different method. How long will you call? So in this way, we understand the UML diagram for it to know how this adapter pattern works. Now comes on the implementation part of this pattern. All right. So here we define two interfaces. Interface fast polling goal fast. Number speed number string and interface spin bowling goal spin. Speed will now be string. So here In the first one, the parameter is number. The second one, the parameter is string. Thereby, two different functionalities are there. Now let's create the objects for those. Class fast bowler implements fast bowling, and let me implement this interface. Return bowling speed speed kph. Create a second object for spin bowling. This will return a different string. All right. Now, in order to combine the functionalities of these two objects, I will be creating one adapter. So focus now. Class adapter implements what? Fast bowling. As we already learned, this will implement the first interface. Okay. And then will provide you the functionality of the second interface. Let me tell you how will it work. So pin bowler, pin bowling, and constructor. Let's say it is taking the pin bowler as a parameter. If it is not provided, then it will instantiate this object. So this dot pin bowler equals to pin bowler. All right. Here we implement our bowl fast method. Return this dot spin bowler dot bowl spin speed dot to string. Look at this, guys. What did I do just now? In this bowl fast method, which was supposed to bowl fast, I implemented this spin bowling method. In this way, you have functionality of the second interface by implementing the first interface. That is what adapter actually does. Now we will create a class that uses this, a client class. Class client. Here we use the fast bowler. We know in the UML diagram, how did it work? We go to the UML diagram. This uses the 1 and this uses 2. So, 1 second. Sorry, forgot to. Anyway, so call client will call this fast bowler to new fast bowler and console log this dot fast bowler dot bowl fast 150. You will see the magic happen here. Fast bowler equals to new adapter and console log this dot fast bowler dot bowl fast 75. The method name is same, but the result will be different, guys. The result will be different. I will show you. Const client equals to new client dot call. Should we run this code? And as you can see, On the first log, it implemented the functionality of the fast bowler. In the second log, it implemented the functionality of spin bowler, the second interface. Two functionalities you are able to use with this adapter. Okay, you have a client object, and this client object is able to use both the functionalities. All right, that is how the adapter pattern works. And why did this happen? Because of this. Okay, in the adapter we are doing. All right, so that is how we implement this. Let's go back to our presentation. Now let's move on to the interview question. Can you explain the adapter pattern and its use cases? So we already saw the adapter pattern deals with interfacing two different objects without changing their implementation path. You want to call new object methods by using an existing interface, but because they don't have something in common, we use a wrapper to connect them. In this way, the adapter pattern works like a wrapper for multiple objects. Okay, for multiple objects, this works like a wrapper to provide the functionalities of new interfaces from the existing interface. Okay, now how does adapter pattern promote the principle of code reusability? How does it do that? So, when you have a client object that is able to call the multiple methods from the adapter, with the help of adapter, when it is able to implement multiple functionalities from the existing interface, what you do is that you use that same client object across your code base. You don't need to define new objects every time. That is how it promotes the principle of code reusability. Alright. So can you provide a real world example where the adapter pattern would be beneficial? Real world examples, see, this can be used in some backend microservices where you are interacting with database, or there is one access control library as well, the Node.js library. It is an access control library. In that also the adapter is used. Okay, so these are the use cases, real world use cases for adapter pattern. What are the potential drawbacks or limitations of using the adapter pattern? The only drawback is that if you have less functionalities, you don't really need to create a wrapper. Otherwise, this will be an overhead. Okay, so there you can use inheritance or create your new custom wrapper or whatever you want to do. But here, if you have multiple functionalities, some large interfaces, then you need adapter. Otherwise, you don't. Could you write a simple code snippet demonstrating the adapter pattern in TypeScript? All right. So the simple code snippet demonstrating the adapter pattern in TypeScript, what you will do is you will simply have two interfaces, different functionalities. You will implement those interfaces in two different classes. You will then create an adapter. Okay. I mean, we don't really need to do complete implementation. You can simply show them, okay, yeah, this will be the adapter, these two will be the classes, and the client will use it in this way, and blah, blah, blah. So that is how you can show the simple code snippet. These are the interview questions. Now, coming to the final slide, the conclusion of this video. We learned about what is the adapter pattern, what are its uses, criticisms, and implementation as well. In the next video, we will study about the decorator pattern, which also works like a wrapper. In fact, in structural design patterns, most of the patterns work like wrapper only. So anyway, that's it for this video, guys. Thank you and bye.